Hello, everybody. My name is Eugene. I'm from GlobalLogic company. I'm leading working group 7 in Nephio. And today, together with Sagar Arora from OpenAirInterface, introduce you Nephio transport use case. My part will to introduce you on high level what is transport at all, what is transport in Nephio, and our roadmap. And then I will switch to Sagar about implementation details. So let's start. And very most frequently asked question, what is transport, what is needed? And it is obviously because most of our team from IT industry, and there is now no anything about transport. This is data center network or local network, and no transport network. So the transport network, it is nature of mobile industry, telco industry. And the telco industry, it is about long distance communication and traffic aggregation. On this picture, you can see 3GPP service-based architecture. It is very popular, and you can deploy it on your own laptop, for example, all these 5G system components, and no transport needed here at all. But on practice, core network components, for example, access management function, IMF, connected with GNB, access radio network, through the long distance communication. Yeah, because core network components usually sit on central office, for example, in center of your country. But around the country, you have thousands of GNBs. Yeah, GNBs sits on point of presence like towers, rooftops, and etc. A lot of locations, right? So transport network is about to provide connectivity between 5 network functions for the long distance communications and traffic aggregation. That's the idea. So N1, N2, N3, N4, and N9 interfaces. It is about long distance communication, traffic aggregation, and target for the transport network. So that's the idea. And let's go to the Nephio, how we're going to implement transport network in Nephio environment. On this picture, you can see in the center a constellation of routers. All of them connection between each other on physical layer with underlay protocols. It might be different configurations, but on logical level, overlay protocols will provide you connectivity between 5G functions. For example, IMF function and GNB function will be connected by MPLS tunnel, which carry on tier N2 interface. The same situation with connectivity between session management function and UPF. It will be provided N4 interface with MPLS tunnel. And for example, connectivity between GNB and UPF will be connected with the MPLS tunnel, which carry on N3 interface. In Nephio, we are going to implement transport capabilities, and these capabilities will give you by default to deploy multiple GNBs on your environment. And all of these GNBs might be connected directly to the transport network, and Nephio do the rest to provide connectivity between functions. That's the idea, to increase level of automation with the integration between transport and the core network and radio network with Nephio environment. And most advanced scenario we're targeting with distributed UPF. You know, distributed UPF, it is a recent interest inside industry we have, and together with transport network, it is give new value with new use cases. So transport network provide connectivity between UPF. On this picture, you can see example of edge application. Yeah, so edge application can request resources on different Kubernetes clusters with GNB, UPF, and point of present location. For example, if every cluster equipped with GPU, graphical processing unit on each Kubernetes cluster, then the application might use these all GPUs, for example, use cases which require high level of parallelism, for example, inference or model training. With a huge amount of GPU, this task might be performed very quickly. So it is very attractive and open new use cases with conjunction with transport network and DUPF together. So we're planning to implement it in release 7. So on this picture, on this slide, you can see a roadmap which we have for nearest future. We are targeting to demonstrate very basic capabilities. It is integration with Nephio and KubeNet. So KubeNet, it is yet another open source project which allow you to manage configurations of routers vendor independently. On the next phase, release 7, we're going to increase complexity of the transport network configuration to demonstrate carrier-grade capability, availability. This means it is a lot of protocols and configurations which will guarantee high availability. And of course, as I said, you demonstrate DUPF use case. And finally, we're targeting in R8 to demonstrate data centers switches configuration. Data centers, that means switches might be configured as a leaf and spine architecture for managed traffic between servers. So it is part of entire 5G system and needs some part of configuration. And Nephio can do this out of the box. So all this feature and this roadmap will increase the visibility of Nephio and interest from the industry. And let's go to the implementation details, and I'm switching your attention to Sagar Arora, please.
Yeah. Thank you so much. Thank you so much for covering all this. Hi, everyone. I'm Sagar Arora. I'm a solutions architect at OpenAirInterface. And I'm going to take you through the implementation details, mostly the aspect of KubeNet, which was just explained. So can you move to the next slide, please? Yeah, thank you. So currently what's there in Nephio? So it's a very high level detail that today in Nephio, the network is managed using, there is one router in the kind environment. So once the Nephio is deployed using scripts which are available to deploy with kind clusters, there is one router which is deployed using container labs. It's deployed. And then to interact with that router, there are certain components of Nephio. There are controllers and specializers of Nephio which are used, and then there is a third-party controller with which we interact to this router. Now, the approach which is there today, it's not really flexible, meaning that we cannot really extend it to multiple different vendors. So right now, it's for one implementation. Somebody can come and do it for another vendor also. That's not big of a deal, but it's just that the effort to do it, it's a big effort. And then there's a lack of support for automated and non-automated environment, because when we talk about switching fabric, we always want that somebody can also change it without any level of automation, right? We go into the switch using command line. If it's X or Y switch, we can use different command lines, and then we just go and make the change. But this change also needs to be populated in the automated environment. That means that automated environment and the non-automated human-used environment both have to be in sync. So that capability in the switching fabric is extremely important. That's my personal opinion. And then after that, it's mostly the implementation, as I explained, that this implementation which we have is not really extendable to multi-vendor environment easily. There's no sort of an abstraction layer cleanly defined, let's say. And then there's a lack of support of certain type of protocols, let's say like precise time protocol, PTP, which is extremely needed in case of a distributed unit. an ORAN and Open RAN distributed unit, let's say in 5G. And when I say it's missing, it's the capability to handle and handle it is declaratively is missing, because right now in Nephio, in the picture which you see here, in the picture you can see that there is a network function, a KBD package. In that package we define all the different interfaces which are needed by a particular network function, and then those interfaces are created automatically using the KPT functions, these pipelines which interact with the specializers, controllers, and the third-party controller then is the one which actually communicates with the data fabric, and it creates these interfaces, it creates these connections inside the switch. So this is what is currently implemented. And now what we are planning to do in R6 is to change it and use components of KubeNet. So let's move to the next slide. Yeah, thank you. So here, what the goal is to replace the middle block there with Nephio specializers and Nephio controllers. We want to use another project known as KubeNet, and especially the project SDC there is soon will be it will be soon. It's SDC is getting a lot of traction, this project, and then KubeNet is also a project which is there to take care of the inventory. So SDC, let's say, first of all, takes care of it maps the Kubernetes manifest to a young-based system in a very simple terms, and KubeNet is an inventory system. So it takes care of managing managing the IPAM and VLAN. It has all the inventory. And then QID apps, these are the applications which communicate with the data fabric. So there can be an application specialized for each and every different type of vendor. So let's say if you have vendor A, vendor B, vendor C. So for all these different vendors, we can have a different application. And then SDC and QID, they are the one which communicate, let's say, on the top layer of Kubernetes, and with the Nephio pipelines, they communicate on the top. And then after that, then the communication with QID app happens, which actually communicate with the switch to make the change. So here we have a clearly defined sort of an abstraction level which is there. So this way, to add a support for multi-vendor switching fabric, it's a bit easier because QID provides a framework to do that. And so that's the beauty of it. And then after that, we can implement protocols like PTP also, and even expand it even more and add all the capabilities of the switch which are exposed, and make the changes declaratively. So this is what we are trying to implement in this particular in the ongoing release. And if anyone of you is interested in being a part of it, you're more than welcome. So thank you so much. And if you have any questions, just feel free to join Nephio Slack and contact us and ask questions, and join our WG7 work group, which on transport. It will really help us to gather your support. Thank you.
Thank you.